Welcome back to the 5G final webinar. It's 5 to 4, so it's time to start with the final session, that is the one about the 5G platform and its sustainability in the future. So we'll have 4 different presentations from each and every 5G site. So the order will be announced by Raymond. Please do so. And let's start with Raymond. The floor is yours.
Okay, thank you very much, Mauro. Let me just go to full screen here. So I must say I have the pleasure of doing this part of the introduction here. So we'd like to give an overview of how 5G Eve is going to live on after the end of the project, and also, you know, to a large extent, what experimenters can expect after the end of the project. So we'll give an overview of the site features now, and I believe this is the order here: France, and I will do the French part, Italy, Spain, and then Greece. And also some of the planned extensions of the different sites which are ongoing. And each of the presentations will also talk a little bit about the use of the different infrastructures after 5G Eve, of course in the context of ICT 19, but there are some other examples too that we will give from the different ICT framework projects. And maybe also a little bit on some of the international and academic use cases, because some of the sites inside of 5G Eve will be used also in an academic context. So if I just give a quick overview here of the status of the French site. So here you can see basically two examples of the radio deployments that are running now. On the left-hand side, you have the infrastructure at the main site in Paris, in Châtillon. And on the right-hand side, this is the site that we have here in Sophia Antipolis, and I think it would be similar to at some of the other sites inside of the French infrastructure. So in terms of the concept of the French site, you can see on the bottom the big yellow cloud. What's a bit unique in the context of 5G Eve, at least, of the French site, is that right from the beginning it was distributed. So you have pieces, of course, which are at the main site in Paris around Orange. But actually, some pieces of the Orange site are actually also in Poland, including some of the ONAP infrastructure or the testing infrastructure. But then you also have radio sites at Nokia outside of Paris in Saclay, at our site in Sophia Antipolis, and at also 2 sites in Brittany, in Rennes and Lannion, which are in the premises of Beacom. So you could already see that within the yellow portion, which constitutes the French site, we already have a significant amount of interconnections between our own internal network. And of course, to the north, this is via the interworking layer that was described a little bit earlier in the webinar. We are connected, of course, to the rest of the 5G Eve infrastructure, centered around the components in Italy, and the portal, which is maintained by our colleagues at Five Tonic. Now, what's interesting too in this picture is you can see there are 2 extensions. One local extension in the region of Brittany on the left, the Blue Cloud, which is something in the context of the 5G Tours project. And you can also see the Green Cloud up on the top, which is an extension much further away in Romania, also connected to the same infrastructure. So you can see that the network is actually growing. The French network is actually growing in time, and in fact outside of the borders of France. In terms of capabilities, so here we have a table showing the current state, and of course you will have access to this information, the current state of the French network. You can see in terms of 5G services, primarily we have EMBB, or Enhanced Mobile Broadband Services. To a certain extent of Release 15, there are URLLC services, and LTE-M and BIOT services also available. In terms of the architectures that we provide in the French site, there is of course legacy 4G operation, but also Release 15 5G NR, in non-standalone mode, but also now very recently in standalone mode in 2 of the sites. In terms of the 5G access features, some of the sites are providing massive MIMO. All sites, I think, provide radio access network virtualization to a certain extent. And today are all running on release 15 specifications, although there will be some upgrades in the near term towards release 16. The core networks are all virtualized DPCs which support 5G services. At least in 2 of the sites, we are running 5G core now also. Control plane, user plane separation is available in all the sites, and as is the service-based architecture for 5G. And of course, interworking with LTE is also available. If we look now at slicing, the full network slicing in the 5G sense today is not available, but it is being planned at least in the core network, and some limited RAN slicing in the near term. Service slicing is available today. In terms of virtualization, all of the components of the French network use virtualization technologies, and this will be increased in the near term as well, as you'll see in a second. There is a certain degree of edge compute, also in particular 3GPP edge computing, and full orchestration, including both virtualized network functions and containerized network functions. Okay, if we now look quickly here at the different ICT projects, ICT 19 projects that are working with the French site. As I mentioned at the beginning, the 5G Tours project, which is spearheaded by BCom, Nokia, and Orange. Orange, both France and Poland. This is focusing on e-health use cases and is reusing very heavily from 5G EVE the ONAP infrastructure, the wireless edge factory VNFs from BCom. And essentially, this will be ensured by the 3 main partners from 5G EVE after the end of 5G EVE. If we look at another project, 5G Victory, this has Orange, EURECOM, and Orange, both France and Romania, involved. And this is focusing on energy use cases. And here again, from 5G EVE, we'll be reusing the ONAP infrastructure, also the open air interface software that we have at EURECOM and in Paris. And of course, the network connectivity that was put in place in 5G EVE will be completely reused. And here there's again presence of common partners between both projects, 5G EVE and 5G Victory. And the same people are involved in this. So there will be a natural handover to the teams inside of 5G Victory to maintain the 5G EVE infrastructure in that context. And finally, the 5G drones project, where the main partners here are EURECOM and Orange. And this is an unmanned aerial vehicle case, or a drone use case. And here we're reusing the EURECOM facility completely. And the handover is ensured by EURECOM and Orange in the context of maintaining the 5G infrastructure. Now, if we go beyond ICT 19, there are other projects in the context of ICT 42 and 56, and also the InfraEA 2020 instrument. And I can list them here quickly. The 5G Records project, which is an ICT 42, and this will be running until the middle of next year. This is making use of the EURECOM infrastructure in Sophia Antipolis. And this is an interesting URLLC use case, which involves time-sensitive networking, where we're really looking at remote, real-time, high-fidelity audio production. So that's a very nice 5G use case. There's the Affordable 5G ICT 42 project, which is also running until the middle of next year, and will make use of the EURECOM facility. And here we're looking at low-cost and open-source solutions for 5G. So some of the work that was done in 5G EVE on end-to-end open source is going to be reused in the context of Affordable 5G. And here we're looking at the integration also of the O-RAN Alliance RAN intelligent controller elements, the CUDU split that we have in the French network, and also some multi-vendor solutions for RAN and core. So it's not just vertical applications, but it's actually also bringing in other network functions on top of 5G EVE other than the ones that were developed in the context of 5G EVE. There's also the Intel IoT project, which is all about next generation IoT paradigms and the convergence between 3GPP and non-3GPP solutions. And this is really about cyber physical systems for factories and farming. This will also reuse the infrastructure in Sophia Antipolis in the context of this project. Finally, from an academic perspective, there's also the upcoming SLICES research infrastructure, which is a pan-European research infrastructure. Now, this SLICES stands for Scientific Large-Scale Infrastructure for Computing and Communication Experimental Studies. This is really all about community-driven experimentation in computing and communications. So this will reuse the existing infrastructure and build upon what we have in parts of the French network today. So what will actually happen with the 5G EVE cluster after 5G EVE in France? I think it's important to mention this here because there has been several specific calls for project proposals in the context of one of the post-pandemic recovery plans in France. And the 5G EVE partners collectively from the French part of the consortium have proposed the French facility to be one of the main 5G platforms to be used to promote the vertical industries in France. So this will be another 3-year project that should start around the end of the 5G EVE project, which will improve the capabilities of the platform, still be based on the same infrastructure virtualization that was put in place in 5G EVE, but now also deploy new private network infrastructure to operate vertical use cases such as Industry 4.0 and e-health. And here also there is the integration of ORAN interfaces and support of third-party solutions inside of the network. So the important message here is that the work carried out during 5G EVE at all the French sites will be enhanced and extended in this context over the next 3 years. So the 5G EVE infrastructure will actually live on now more or less the same way as it has for another 3 years and be enhanced in the context of this recovery plan. If I can end here on some of the international interactions, a subset of the French network in Sophia Antipolis will continue to promote the 5G EVE infrastructure in Linux Foundation projects and other open source initiatives. So there will be continued integration with the Magma Foundation for proof of concept and testing of evolving 5G telco functions. And we're also looking at uses in ORAN proof of concept context and the potential evolution of ONAP and testing using the 5G EVE open source components. This is an important activity that's not going to stop. And we're also investigating tighter interactions with the United States National Science Foundation Platforms for Advanced Wireless Research, which is an academic initiative where we're looking to do continued integration with testing methodologies and software mutualization. So a lot of the things that were developed in the context of 5G EVE are being shared now. The open source components are being shared with international partners so that we can mutualize development and strengthen the different methodologies that were put in place. If I could just very quickly publicize a little bit, there will be one final tutorial in the context of 5G EVE, which will take place on the 17th of June. It'll be a 45-minute online tutorial where we will go provide details on some of the open source tools that were used in the French site and developed in the context of 5G EVE. So there will be an overview of the way ONAP was used, the OpenShift, Red Hat OpenShift technologies that are used inside of the clusters in the French site, open air interface, and also the recent extensions that were put into Magma. We'll go over some of the challenges in deploying telco containerized network functions, so functions like EPC, 5G core, and RAN inside of containers, all in an ONAP framework. And finally, we'll give an overview of the vertical application deployment inside of OpenShift. This will be a demo of the 5G drones on 5G EVE infrastructure. So that will be the content of the upcoming tutorial. So that is the end of the French component. I'd like now to pass it over to my Italian colleague.
Okay, thank you, Raymond. First of all, can you hear me?
Yes, all good.
Okay, so let me share. And please also confirm that you can see my screen. Can you? Because I'm using two screens and it usually messes up everything.
Yes, I can.
Okay, so you're seeing the first slide. Very
We're
good.
seeing
Okay.
the not the slideshow, the other one.
I beg your pardon?
We can see your first slide, but also on the right-hand side, we can see, let's see, the next slide or whatever. So it's
Seeing the wrong screen.
Yeah, you
How
have to
about
speak.
now?
That one. This is okay.
much better.
Much better, yeah. Thank you.
Okay, yeah, I've learned the tricks. I usually get very confused with these multiple screens, but hopefully now it works. Okay, so thank you, Raymond, for handing over to me. Briefly, I would like to go over the status of the Italian site and go over the legacy, the 5G legacy as far as the Italian site is concerned. Those of you who have been in previous webinars and have a good memory may recall a slide like this one, because it was already presented a few months ago. Anyway, now this shows the consolidated status of the Italian site. As you can see here, we have 3 red boxes surrounded by these red dotted lines. They referred to the 3 main pieces of infrastructure that are that effectively constitute the Italian 5G test site. Starting from the bottom, we have the installations, the infrastructure installation, the facilities at on TIM premises in Turin, counting 2 core installations that are used for different purposes. I will refer to one of them later when I talk about the interaction with ICT19 projects, and also hosting the global, let's say, the EVE-wide interworking layer that is used by all the other 5G partners. From here, there's also the connection, and we go to the upper left corner of the slide to the field installation, the field core installation that has the real live coverage in the city of Turin, where all the use cases have been tested. And I would like also to mention that here we have the connection to the one M2M servers that are also part of some of the use cases that were tested. And finally, we have a connection on the upper right corner to Politecnico di Torino, which is one of the partners through the CNIT consortium. Here we have the local Open Mano orchestrator, and we have the NFV infrastructure where all the applications for the use cases have been hosted. I would like also to mention, forgot to say it now, that there is a fiber connection between Politecnico and the TIM premises. They are just a few kilometers away. So for all intents and purposes, the NFV infrastructure and the MAN orchestrator are as if they were on the same site. Also, there is another orchestrator that was installed by Ericsson, which is used by 5G EVE and is on the TIM Lab premises. As you see, this slide recaps what I just said with one addition, the data shippers for the metric collection that, of course, are all located on the applications, so on the NFV infrastructure of Polytechnic. Okay, going back once more to this slide, you see that here we have also the brown links going on the one hand through IPsec tunnels to the other major 5G EVE sites, Madrid, Paris, and Athens, and 3 more brown links that instead represent the interconnection with the other 3 ongoing ICT 19 projects that have a partnership, running partnership with 5G EVE right now. These are 5G solutions, 5G tours, and 5G and 5 growth, and they represent not only 3 different projects, but they also cover 3 different use cases. We have smart energy for 5G solutions, smart tourism for 5G tours, and smart industry for 5 growth. The interconnections are depending on the test cases, because for some of them it is very important to have a coverage on site, a coverage on the city of Turin where the use cases take place. So the interconnection goes through either the field core or through the trial core, or directly, as in the case of the 5 growth smart industry use case, there's a VPN with COMAU premises that will be illustrated here. So a few words about the integration and status of ICT 19 projects. Starting with 5G solutions. 5G solutions right now doesn't require any infrastructure improvement. There are 3 use cases that are being tested for smart. They all go under the smart energy hat. They will be integrated in the 5G EVE portal for the Italian site, and as the 5G solutions approach goes, this will happen through 3 cycles, with cycle 1 already complete and tested fully, and cycle 2 ongoing. Some open points are the integration of the 5G solution service orchestrator with the 5G EVE interworking layer that will be worked on in the following months, and the definition of requirements for the cloud edge resources that are needed by the project. As far as 5 growth is concerned, as I mentioned before, we have a VPN connecting the COMAU premises to the Steam site, and from there, as I showed before in the first slide, to the local orchestrator, the EVE Cloud hosted at Politecnico Torino. Here too, we have ongoing work specifically to integrate the 5 growth orchestrator and connect it to the interworking layer. Finally, 5G tours. We have some use cases of phase 2 that require the use of the 5G infrastructure, and that goes again, brings with it again not just the test site, but also the orchestrator features. These will be mostly related to the smart tiers use cases. And finally, what is left behind by 5G EVE? Of course, the Italian site will guarantee that the local infrastructure will be up and running and will be maintained in the status described in the 5G EVE deliverables and available by June of 2021. So this is what the Italian site guarantees. Troubleshooting is guaranteed. Of course, we have to understand what troubleshooting means. It's foreseen that for things like, for example, running an experiment and then finding out that the experimenter cannot access the log files, then troubleshooting means that personnel from 5G EVE will be called upon and make the log files available or solve the issue with the log files. Troubleshooting does not mean, however, to, for example, have oh, look, my blueprints do not work. What is wrong with them? There are already rules and manuals produced by 5G on how to create a blueprint. It's a work that costs some time and effort. So preferably, this is the task of the experimenters, and no troubleshooting is instead guaranteed there. The reference person is not myself, but Mauro August from TIM, and this is just about it. So back to you, Raymond.
Okay, so now let me just check. I forgot the order here. So I think we have our colleagues from Spain now.
Yeah. Okay. Can you hear me correctly and can see the screen?
Yes, I can. It's fine.
Okay, thank you. So this is the Spanish site, 5G Spanish site, 5tonic. This is the structure of the infrastructure of 5tonic, which is available for 5G. It's not easy to see because it's a complex one. But basically it is constituted by a radio access network infrastructure in which we have 4G support in bands 7, in bands 20, where we have also narrowband IoT and LTE-M support, and in band 42, where we have LTE TDD. And also we have support of 5G radio access. So it is in band N78, and it is supported by different technological solutions, Ericsson DOTS, also massive MIMO solutions, and also conventional AT8R solutions, both indoor and outdoor. Okay, this is the first part of the infrastructure that we are supporting. This radio access is connected to a different set of cores. There is the original one, the legacy virtual EPC supporting 4G access. Then we have two 5G virtual EPC for supporting non-standalone access. One is a permanent one, which is deployed in the lab. The another one, and the second one, is deployed in a portable unit, what we call a 5G backpack, that allows us to move coverage into different areas beyond the lab. And finally, there is a 5G core for supporting standalone connectivity, which has also a number of network functionalities deployed that you can see in the lower left side of the slide. Okay. Additionally, we have all the processing infrastructure required to support the orchestration, the SDN capabilities, also the different processing capabilities that are required for the support of the different use cases, and also the measurement infrastructure that is required for collecting the different KPIs associated with the different use cases. And last but not least, we have a second independent 5G core, NSA, non-standalone access, provided by Nokia, that was deployed at the lab for the support of a specific use case in the context of 5G. Okay. In the next slide, we have the different capabilities, features that are supported in the lab, in the case that they are already supported at this point in time, and if not, when we plan to have them supported. Okay, related to 5G services, architecture options, access features, spectrum, core network capabilities supported, slicing, virtualization, edge computing, and orchestration, more or less the same one classification that was used for the French site. Okay. As you can see, many of them are already available, and some of them obviously will require that we have technical solutions available in the market to be deployed here. And all these infrastructure and these functionalities and capabilities are used to obviously to support 5G use cases, but also for, as has already commented by other sites, support use cases coming from the ICT 19 call projects. Okay, in the case of 5G, we support a use case from the 5 Growth project, which is called Connected Worker Remote Operation Quality Equipment, where Innovalia, which is a Spanish company, is the vertical customer. And the objective of this project is to improve what they call the zero defect manufacturing service that they provide, allowing for the remote operation or configuration of a coordinate measuring machine. This coordinate measuring machines is a machine that is put in a factory in order to make measurements of pieces manufactured by tools and evaluate if they are being properly machined, if they are correctly fabricated, and in this way the tools are operating correctly. Okay, this is very expensive to do with the current technology, and the idea here is to introduce 5G in order to ensure a more economic operation, also a more easier operation, even allowing for not being present the people who have to configure this machine. In the case of how this project is integrated with 5G platform, you have the picture in the right side. It's a nice one in the sense that 5G, if provided infrastructure functionalities, become part of the flow of the configurations of the different slices and use cases that are being defined by 5G Growth, that also inherit some functionality coming from previous project, in this case in 5G Transformer. So in that sense, it shows the continuity and the inheritance of the different European projects in order to achieve a new use case support by a new one. Okay. What will happen with 5G after the, by the 5G Spanish site, Fivetonic, after the conclusion of the project? First of all, you must take into account that Fivetonic existed before the project started. It was created in 2015 and started its activity in 2016, and it will continue its activity beyond the final or the end of the project, the 5G project. But for us, it is very important that we extract value of the already deployed 5G platform in order to enhance the objectives that we have as a lab in terms of co-creation of platform for 5G and beyond 5G use cases. In that sense, we are open to cooperate with different European projects through the different partners or members of the laboratory, members or collaborators. And here you have the 4-1 that we are currently supporting. We have compromised support through the members, because we have no legal entity as a lab, and it should be the members of the lab, that the ones that participate in the project. This is the case of AI at Edge project. It's a use case related to drone operation in which Ericsson is participating, and also Aerotools, which is a Spanish company that we hope to become a Fivetonic collaborator in the short term. Also 5G Dive, which is a cooperation project between Taiwan and the European Union. We are cooperating here in a use case related to Industry 4.0 with participation of University Carlos III in Madrid, Ericsson, Telcaria, and Telefónica. 5G Induce, in which this project wants to develop an open 5G orchestration platform for the deployment of advanced 5G net apps. And here we are present through Ericsson as a member of Fivetonic, and also collaborators like Fivecom, which is a company coming from Valencia in Spain, ASTI and Yerba Buena Virtual Reality. And finally, we are also involved in the XAX project, which is the flagship project aiming to define the vision of the European vision, let's say, of the future 5G mobile systems that will be deployed by 2013 or even earlier. And this project for us is quite interesting because marks, let's say, the way towards the future and becoming also involved in the next generation of mobile communications and being able to support the different use cases that may come from that. So in conclusion, we have, let's say, guaranteed by external means the continuation of the activities of the Spanish site as an independent laboratory, but we are open to the cooperation with different European projects, and we want to evolve and to support the 5G platform in order to extract value from it. So that's it from my side. I think I have to hand over to the Greek partners.
Okay, thank you.
Thank you.
Let me share my screen.
Velissarios,
Okay. Can you hear me?
Yes, we can hear you.
Okay, thank you. Well, my name is Velissarios Gezerlis. I'm working at the OTE Research Labs, and I'm responsible for the management of the Greek site of the 5G. And I will present you a brief overview starting from the architecture, the main architecture, where we have two platforms, one from Nokia and one from Ericsson, and also we have a platform from Wings, where we have the OSM and the Kafka. 4 use cases are supported from this architecture. The one is Industry 4.0, which is an AGV and is supported by Ericsson and developed by Ericsson. The other is the smart energy, resolving outages and ensuring the stability of smart grids by means of 5G, and is developed by Wings. Smart cities application focused on connected ambulance. This is by Nokia. And the other one is smart city safety and environment, which responsible is Wings. In this slide, you can see the whole infrastructure of the Greek site, which all this infrastructure is developed at the OTE Labs. We have, as I said before, one Ericsson core, not standalone, which is installed and fully functional for the AGV use case. We have a Nokia 5G standalone version platform, which is fully functional for e-health use case. We have Wings IoT platforms, where we have the utilities and environment safety cities use cases that are tested with Nokia and Ericsson platform work with these two platforms. We have an OSM, which is interconnected to the Ericsson and Nokia platforms. Also, the Greek site is interconnected to the interworking layer of Turing through a secure tunnel, and also to the portal in Spain. A Kafka broker is also installed, up and running, and interconnected to the central Kafka. Also, a performance diagnosis tool for post-process analytics on the collected metrics and KPIs is developed by Wings, and it was presented before by Vangelis and his colleague Yannis. We have defined all the KPI methodology and the metrics, so have measures from the network, the user, and equipment. Data zippers have been developed from Nokia and Ericsson in order to send the measurements to the Kafka broker. Test plans and blueprints have been developed for the 4 use cases. Also, the Greek site participates, as you heard before, in the multi-site use case. So we have an interconnection with the Spanish site, and also we have make a lot of tests successfully with a multi-site use case that, as you have seen before. Also, end-to-end tests have been executed for the use cases, and the metrics of these tests have been uploaded to the Kafka. This is the table of the main capabilities of the Greek site. As you can see here, we support the EMBB, URLC, and MMTC service types, and this is supported by both Ericsson and Nokia. They supported by release 15, and concerning the application architecture options, Nokia is in a standalone version, and Ericsson is Nokia is in a standalone version, yes, and Ericsson in non-standalone. Also concerning the 5G access features, flexibility numerology is supported by Ericsson. Multi-user MIMO is supported by Nokia. And also latency reduction is supported by both Ericsson and Nokia in release 15. The core network supports 5G, 5GC, and interworking with the LTE, SBA, CAPS, and all that are supported by both Ericsson and Nokia. Also slicing, as I said before, EMBB, URLC and MTC slice types are supported by Nokia, and service slicing orchestration is supported only by Nokia. Also virtualization is supported by Ericsson, and vertical virtualized application deployment support supported by Ericsson and Nokia. Edge commuted is not supported, and orchestrator it has been developed by Nokia and an internal OSN by Wing, and an internal OSN by Nokia. In this slide, you can see the 4 use cases that we have. The AGV industry, where we have an AGV robot, the e-health smart ambulance, where we have here a picture with the sensors and an implementation of the health. The use case Wings for smart energy, smart city is some picture of the implementation, and from Wings, a KPI validation tool that was described before by the presentation of Vangelis and Yannis. Also, you can see here in this picture the participation of the QuickSite in the multi-site use case is an interconnection diagram. Also concerning the ICT 19 projects, 2 projects rely on 5G Greek site infrastructure, 5G Greek sites infrastructure. These are 5G tours and 5G HER. In 5G tours, have developed an extension site at the Athens International Airport. The 5G tours utilizes only the Nokia's platform, 5G EPC, and we have installed at the airport 2 outdoor and 4 indoor installed antennas, pair of antennas, 2 installed BBUs. We have installed probes in order to measure the KPIs. We have installed some servers, like a streaming server, in order to support some of the use cases that we have in 5G tours. We have an interconnection line from the airport, Athens Airport, to the 5G infrastructure at Psalidi OT Labs 10 Gbps line. All the use cases are connected to the 5G core of Nokia. Also, we have user-end equipment and also an artificial intelligence enhanced Mano and the performance diagnosis tool in combination with a real-time KPI measurements from ACTA company, who is responsible for the measurements using probes. And this is an innovation that we are implementing during the 5G tours. In this 5G tours project, 6 use cases will run. We have already tested a lot of them. The one is smart parking at the airport. Ground-based vehicles they are follow-me vehicles with cameras which transmit for ultra high definition video to the offices of the airport. Also, airport evacuation. This is a very interesting use case in case of emergency, how to evacuate a terminal. And also augmented reality and virtual reality student bus excursion and exhibition, where a team of students use augmented reality, virtual reality application connected to the 5G of Nokia's platform, the 5G, in order to visit an exhibition at the airport. 2 more use cases is the remote health monitoring and also optimal ambulance routing, which has to do with the e-health, that also will be run at the airport and also at the OTE Labs facilities. This is the interconnection diagram of this use case of 5G tours. So we have here the use case 10, 11, 12, and 13 that are connected to the Nokia's 5G antennas at the airport. There are some also servers that support these use cases. Through the Nokia's BBUs, all the traffic goes to the through a 10 Gbps line to the 5G EPC of Nokia. The same is for the use case 6 and 9, which is for remote health monitoring and optimal ambulance routing, has the same path for reaching the 5G, to have access to the 5G of Nokia. So the 5G EVE platform is used by 5G tours, and the 5G tours will use blueprints and it will use the end-to-end service of the 5G EVE, and also will use the interconnection layer in order to reach the IMDEA Athens sites. Let's move to the next IST19 project, which is the 5G HERD. Also in 5G HERD, we have an extension site at the area of Megara, is a small city out of the Athens. There we have an implementation and we use only the Ericsson platform of 5G EVE infrastructure of the Greek side, and we implementing an aquaculture use case at the Skironis company. We have also a 10 Gbps line interconnection from Megara to Hotel Labs. We are now at the phase where we are installing the antennas of the Ericsson and the BBU, and all the other infrastructure is ready, up and running, and we are ready till the end of the June. We will have ready all the infrastructure in order to run the first real tests. Also for the 5G HERD, we use the 5G Greek site infrastructure from the Megara to the OTE Labs, and we use all the 5G REST APIs for controlling and consuming metrics and KPIs. Blueprints will not be used in this use case. And finally, for concerning the sustainability and the maintenance of the 5G EVE Greek site after the finish of 5G project, we can say that we will maintain, can guarantee that we will maintain the Greek site since the three main partners concerning the 5G tours, OTE as a site manager, Nokia of Greece as a 5G provider, and Wings as a provider of OSM and Kafka, participate also to the 5G tours project. We are partners to the same project. Also, the same is for 5G HERD, where OTE site manager, Ericsson as 5G provider for 5G HERD, and Wings for as a provider of OSM and Kafka also participate to the 5G HERD project. So we can guarantee for till the end of these two projects that the Greek site will be up and running and will support all the use cases that I described before. This is my presentation. Thank you for your attendance, and Raymond, you can get the ball back.
Raymond has to leave, so sorry for that. So maybe I don't know if Mauro, you can take the board from now.
Yes, I would like to thank all the four speakers. So it was really a very comprehensive presentation of all the features, the facilities, and also the opportunities of continuing to work with us also after the official end of the project that is set at the end of June. Okay, we have completed all the agenda with all the presentations that we have for today. It is once again time for any questions, if you have some.